doing math today. We're going to be looking at some more typical algebra than we looked at before. We're also going to be doing some geometry, so coordinate planes and graphing, and then working with triangles and other types of angles, how to find angles, and some polygons. So that's kind of overview of what we're doing today. And we're going to be trying to, as much as possible, implement Kaplan method. We're going to see some really good instances of how backsolving and picking numbers can work very effectively when you might not even know to use them. And so we're going to look at some instances of that as well. So, did anyone watch the instructional videos before class? Yeah? Good, that's great. I'm glad to hear. Because I think that they really are very helpful in getting you prepared to take in information today. So I'm glad that we got some people watching this. And if you find that you're still unclear about some things that we talk about today, you can always watch the videos again and have someone tell you about all this stuff again. And I can always make it sink in a little bit more. Did you have a question? Oh, sorry. Okay. Okay, so we're just going to very quickly warm up with some absolute value problems. So, does everyone remember what absolute value means? Sarah, Sarah Jeffries, can you tell me what absolute value?
Yes, it's kind of saying that whatever you get in the bars will end up being positive. It's like on a number line, the distance, it would be from 0.
Yeah.
So for like -5 and 5, it would still just be 5.
Yeah, perfect. That's exactly right. The distance that this number lies on the number line from 0. So if we're trying to solve this problem, we've got an equation, but we've also got absolute value. How do we go about finding how many values can we possibly get for x here? 2, right, yeah. So unlike with a lot of other equations where we're only finding one value, like we've done thus far, we're going to be finding 2 values with absolute value. So what's our first step in breaking this problem down? Smia?
You said 6 minus x equal to 5 or -5.
Yeah, perfect. So we're going to set it equal to 5 and -5. So we actually get 2 equations now. Because as Sarah said, we're looking at the distance from 0. So on a number line, 0 is here, 5 and -5. 6 minus x could be equal to either -5 or 5. So that's why we're making these 2 equations here. So then what's our next step? Susanna?
To subtract 6 from both sides?
Yeah, we'll subtract 6 from both sides. So -5 minus 6, what do we get? Yeah, -11. And our final step, James?
We just distribute the negative.
Yeah, exactly. Or multiply through by -1, however you want to put it. So we end up with 2 solutions for our absolute value problem, 1 and 11. Any questions about that? Okay, great. So we're going to move on. We're on page 199 today to start with. Now, just a quick review. Eddie, can you run through the Kaplan method for us?
What is the question? What information am I dealing with? What information?
Yeah, and Maggie, what are we looking for when we're talking about what can I do with the information? What are some of our options that we have?
You can do the back solving or plug in different numbers.
Yeah, exactly. We can back solve, we can plug in different numbers, and if those options aren't available to us, we might be doing straightforward math. Yeah, very good. Okay, let's turn to page 200 and talk a little bit about exponents. Now, these rules might seem like an elementary school review type thing again, but what we try to do in class is only do the stuff that you have to do for the SAT. And these are the only exponent rules you're going to need to know on test day. So whittle it down so that you can just focus on this and not get distracted by other things. So on page 200, exponents. Sarah M., can you look at that first box in the upper left-hand corner and explain to us what happens when you have the same base and different exponents multiplied, same base and different exponents multiplied together?
It adds together the exponents.
It adds, yes, exactly. So, like it says there, AB times AC equals A to B plus C. So important here is remember you're keeping the same base, adding exponents. So in our example right there, 4 to the third times 4 to the second, how else can we write that? Obi?
4 to the 5th.
Yeah, exactly. 4 to the third times 4 to the second equals 4 to the fifth. You're going to see how this is going to become really important when we look at some practice problems. So similarly, now that was with multiplication. What do we think probably happens with division?
Subtraction.
Subtraction, exactly. So we've got A to the B over A to C. We're going to subtract A, B minus C. So we have similar problems up here. 4 to the third over 4 to the second. Mark, what's our answer going to be?
4 to the first.
Yeah, exactly. 4 to the first equals 4. Perfect. Okay, let's go down to where we're looking at different bases, same exponent. So we've got A to the C times B to the C. Maggie, can you explain to us what we do in that instance?
You would multiply A and B and raise them both to the power C.
Yes. So here, we're multiplying the bases, raise the product of the bases to the same exponent. So in our example, 3 to the 4th times 2 to the 4th. What do we get there, Sam?
I'm sorry, you get, it's just 6 to the 4th.
Yeah, exactly, yeah. Yeah, so just remember that this only works when we've got something that's the same exponent or the same base. So that's when these rules are going to be in use. Now, if we've got a number raised to an exponent, and then that whole thing raised to another exponent, what are we going to do in that instance, Sarah J?
You multiply the exponents.
Yes, we multiply the exponents. So A to the BC. So in our example, 4 to the third raised to the second, what are we going to get, Sarah?
4 to the 6th.
Yeah, 4 to the 6th. Okay. Does everyone have all this down? Okay. All right, great work so far. So when we have a negative exponent, Eddie, can you explain to us what happens?
Wait, which one was that?
Looking at the third row of the left column.
So you put it 1 over, A to the exponent. You just put a 1 over top of it.
Yeah, exactly. We find the reciprocal. So A to the negative B, we find the reciprocal here with the base to the exponent. So our example, 4 to the negative third, what are we going to get there, James?
1 over 4.
Yes, 1 over 4 to the third. Perfect. Great. Okay, now this one's a little bit more tricky. When we've got a fractional exponent, we're looking at the third row and the right column here. When we have a fractional exponent, Maggie, can you explain to us what happens?
The exponent on the bottom of the fraction will become a square root sign, and the one on top will go underneath the number.
Yeah, exactly. So the bottom one goes in the elbow here, the square root sign. A to the B goes on the inside. So 4 to 3/2, Sumia, what are we going to have there?
The square root of 4 to the third.
Yes, very good. Okay, and then you probably know any number raised to 0. Mark, what is any number raised to 0? 1, yes. So I know you all know that, just reviewing. And then one other thing to remember is that if a squared equals, in this example, 81, then a, we've got two options for what a can be, didn't we? What are our options, Sarah?
9 and negative 9.
Yes, 9 and negative 9, because remember last week we worked with positive and negatives, and we multiplied two positive numbers together, or sorry, two negative numbers together. Always going to get a positive number. Okay, so, and then two more little rules down there at the bottom dealing with roots again. If we've got, is a way to simplify when we've got a fraction under a root? What can we simplify that to, Susanna?
The square root of like a over square root of b.
Square root of a over square root of b. And so that can be really useful if we have something like the square root of 4/9. Now that seems sort of dubious, but if we break that down into square root of 4 over square root of 9, then that's something we can work with. In a, what do we get in that?
2/3.
2/3, yeah. Okay, so let's look at that. Oh, sorry, there's one more. One more. This is also really useful. You're going to see this. You're going to see a lot of this kind of number manipulation on the SAT, and so just being able to work with numbers and get them in different forms, you're going to see is very useful. So that's why we want to go over things like this so that they're fresh in our minds and we know what we can do in different occasions. So last thing to look at, square root of AB. So if you've got a number AB that you can't take the square root of and get an integer, we can do something to break that apart so that it's easier to work with. Aline, can you tell us what we can do in that?
You take the square root of a times the square root of b.
Yeah, so if we can break this down into factors. So the square root of 1, square root of a times the square root of b. So an example of that, 75, we don't know what the square root of 75 is, but are there numbers that factor into 75 that we can at least take the square root of one of those?
25 and 3.
Yeah, 25 and 3. So we're going to break 75 into 25 times 3. Can't take the square root of 3, but at least we can take the 25 5 times the square root of 3. So we've broken that down to a form that maybe we could be able to eliminate some issues there if we're running into problems, working through a problem on the SAT with this kind of information. Has everyone got that down? Okay, so let's look at number 1 there on page 200. And Mark, could you walk us through how you would go about doing that problem, number 1?
We're going to introduce x and y to the x times 2 to the third equals 2 to the 7, and 2 to the y to the squared equals 2 to the 12. What is the value of y minus x? So I guess you could see for 2 to the x times 2 to the third would be 2 to the fourth.
Yes, exactly. So, and which rule are you using to get that?
First one.
Yeah, the first one. So how when we are multiplying the same base to different exponents, we're adding the exponents. So that is 7, that's 3, we've got x equals 4. Great. And then what about for y? How are we going to find y?
2 to the y squared would be, it's going to be 2 to 6.
Yeah, exactly. So when we take a base to an exponent, raise the whole thing to another exponent, we multiply it together. So if we've got y times 2 equals 12, we can figure out that y equals 6, just like Mark said. Very good. And what's our question asking us, Aline?
What's the value of y minus x?
So y minus x, what are we going to get there, Aline?
2.
2. Yeah. So that's our answer, choice number A. Great. Very good. Thank you for walking us through that. So let's go ahead and turn to the next page, we're going to look at inequalities. Now, it's something you're also probably going to be pretty familiar with, but we do want to cover just a couple of really important rules. So on page 201, when you multiply or divide an inequality by a negative number, what do you have to do? Sam?
Sorry, when you divide an inequality by a negative number, you have to switch the inequality sign.
Yes, exactly. Yeah, so always remember, watch out for your signs. We talked about how the SAT likes to trick you up on getting your signs right. This is another place where they like to do that. If you're working with an inequality instead of an equation, if you multiply by a negative number, instead of just keeping the sign in the middle the same, you gotta flip the inequality. So if it was less than, now it's greater than. Great. And now, single variable equations are usually solved for a specific value. However, inequalities can be solved for what? Any ideas, Maggie?
A set of values.
Yeah, a set of values. So when you get an inequality, you're going to get something like 2x plus 6 is less than 4. And then you're going to end up getting something where you can find out that x could be less than a set of numbers, because unlike equations, they're not set equal to one thing, they're set equal to a range of values. Similar, the variable is going to be set equal to a range of values. So let's look at number 2 there on page 201. We've got if 3x minus 7 is less than 8, and negative 6x plus 2 is less than negative 22, how are we going to go about solving that? Susanna?
For the first one, I mean, are you just doing one at a time?
Yeah, you just do one at a time. Yeah.
Okay, so you'd add 7 to both sides.
So 3x less than, yeah, thank you. And then what would we get for x?
Divide by 3. So 5.
X less than 5. Okay, great. And then what would we do over on this one?
Subtract 2.
Okay. 6x minus, so we get 24.
And then divide by negative 6. So flip the sign.
Flip the sign, good, very good.
4.
4. Yeah, good work. So now we know that x is less than 5, but greater than 4. So another way we can write that is 4 less than x less than 5. So x is between 4 and 5. This is a gridded answer, so you can now grid in any answer between 4 and 5. Now, do you notice that there's not an equal sign underneath these inequality signs? So the answers can't be 4 or 5. They've got to be 4.1, 4.2, 4.3, something along those lines. And you can put in any of those answers. Any of those would be acceptable. So this ties in well to what we were talking about with inequalities earlier as well, looking at flipping that sign, but also looking at getting multiple answers for a problem. So we're going to look at absolute value one more time, page 202. Now, like Sarah explained earlier, absolute value is the distance from 0 on a number line. And because distance cannot be negative, like she said, absolute value is always positive or 0. When it's 0, that's the only time that there's only one option for an absolute value equation, is if it's 0. So there in our little chart, if our number is 7, what's our absolute value? 7. If our number is negative 7, what's our absolute value? Also 7. If our absolute value is 8, what could the number be? 8 or negative 8. And if the absolute value is n, we could have, yes, exactly, thanks. N or negative n. So let's look at another example that's similar to what we did before we got started. All right, so if x is less than 0, and the absolute value of x minus 4 over 2 equals 14, what is the value of x? Okay, so to start with, let's look at the Kaplan method. What are we being asked to find here? Mark? Yeah, we're just being asked to find x, which we know is inside an absolute value sign. What information am I given? Sarah J?
That x is greater than 0, and that
Or-
in the equation that.
Is it greater than 0?
Oh, sorry, I meant just less than. And then that in that equation it equals 14.
Yeah, so we know that x is less than 0. Just glancing at those answer choices, what can we do immediately? Yeah, we can eliminate D and E. Neither of those are less than 0. So by paying attention to some of this information we're given, we can just get rid of some of those answer choices. So even if you didn't even know how to work through this, we've talked about how if we can eliminate at least one answer choice, it's to our advantage to go ahead and guess. And here we can eliminate 2 right off the bat. So we know how to work through this problem, so we don't want to guess, we want to keep going and get the right answer. So we can work through this like we did the first time around, but because we have answers in the, or sorry, we have numbers in the answer choices. Sam, do you remember what other Kaplan method we can use if we have numbers in the answer choices?
You can start with the middle number and determine if you're high or low.
Exactly, we can back solve. Yeah, so we've got, well, we're down to 3 numbers here, so what's our middle number now?
So B.
Yeah, B. So let's plug in -16 and see how that works for us. So we've got x is less than 0, and we plug in -16 minus 4 over 2, absolute value. We're going to see if this equals 14. So -16 minus 4, what's that?
20.
-20 divided by 2, we get the absolute value of -10. Doesn't equal 14, does it? So that didn't work. This is sort of complicated to see if it's going to be greater than or less than, but what number do you all want to go with to just try to find the next? -24. Okay, we'll try with -24. So if we put -24 in there, absolute value, 14. So -24 minus 4, what's that? -28. And then when we divide that, what do we get over there? Thank you. Yeah, -14. And we know that the absolute value of -14 does in fact equal 14. And like Mark said, we were looking for x. So are we finished? Did we find x? Yeah, we found x. So there we go. Answer is A, -24. So, okay. Now we're going to look at kind of how these things all fit together, looking at number lines. This will also probably be something you're pretty familiar with, but we're just going to run through it pretty quickly. On page 2 of 3, we're looking at, we've got a number line, and we want to see what happens when we raise these different numbers to exponents. So right now the numbers don't have values, so we're going to give them values. So we've got -1, we've got 1. Say x is between -1 and 0, so let's call that -1/2. W appears to be greater than -1, but less than -1 and greater than -2. So we'll call that -3/2. On the other side, we'll have 1/2 and 3/2. So I'd like you to just make a chart here. Looks something like this in your book, where we've got, just to see the patterns, and we have talked about this a little bit before with positive and negative, or with even and odd exponents, but just to reiterate, x squared, and x cubed. We can just put that on top of your chart. We're going to run through what happens when we raise these different numbers to exponents. So if our number is -3/2, and we square that, Maggie, what happens? It becomes positive, and what would it be? 9/4, yes. So 9/4. So if you got a number greater than 1, or sorry, if its absolute value is greater than 1, then the number is going to be, the absolute value is going to increase. And then sometimes it'll be positive when we've got an even exponent, but then what happens when we've got an odd exponent? Sarah M., if we raise negative 3/2 to the third power, can you tell us what would happen?
You just.
Would it be positive or negative?
Oh, negative.
It would be negative, yeah. And Sumia, what would we get for that fraction?
27 over 8.
Yeah, 27 over 8. So we're getting that by saying 3 to the third, which is 27, 3 times 3 times 3, over 2 to the third, 2 times 2 times 2, which is 8. So we've got this flip-flop thing going on here. All right, let's move on to negative 1. X is negative 1. What's x squared?
1.
1. Good. And x cubed? Negative 1. So when it's 1, it's always, the absolute value is going to stay at 1, but it's going to flip-flop back and forth between negative and positive. Now what if we have, this is where it gets a little bit different, negative 1/2. So we've got an absolute value less than 1 here. Negative 1/2, when we square it, Shaz, what do we get?
Quarter. Positive.
Positive and a quarter, 1 over 4. And then, Scott, when we cube it, what do we get?
Negative.
We get a negative, and do you know what that fraction would be? 1 over 8. Because again, 1 stays the same, 2 times 2 times 2, 8. So now what we've got here is when we have an absolute value starting out of greater than 1, the absolute value is getting bigger. We have an absolute value starting out less than 1, absolute value is getting smaller. These fractions are moving closer to 0. 1/4 here, negative 1/8. We keep getting closer and closer to 0. So going on to the other side of the number line, we've got 1/2. What are we going to have for x squared? Anyone? Claire? Maggie, can you help her out? 1/4, yeah. So we square the top number, so we get 1 squared, which is always 1, and we square the bottom number, 2 squared, 4. What about x to the third? Susanna?
Notice you have positive line.
Positive 1/8. So here we're getting the same absolute values, but we're not getting the flip-flopping signs because we started out with a positive number. Now, like we said earlier, 1 always stays the same. So if x is 1, what's x squared?
1.
And x cubed? Very good. And then our last one, we start out with 3/2. What's x squared going to be? Sam?
9 over 4.
9 over 4, yep. And of course, we're still positive. And then x cubed, Sarah J?
27 over 8.
27 over 8. So I just wanted y'all to make sure you had it clear in your minds about the patterns that we're going to see here. So once again, if we're starting out with a number that has absolute value greater than 1, you're just going to keep getting greater and greater absolute values. Starting out with a number that's absolute value is less than 1, you're going to get smaller and smaller absolute values. And then the sign depends on the sign that you're starting with, and if you have an even or odd exponent. Do you have any questions about any of that? All pretty clear? Okay, good. Great. Okay, so looking at number 4 there, Sumia, could you read that problem and walk us through how you would work through it?
On the number line above, each of the letters C, W, X, Y, and Z correspond to a different number. Which of those letters could correspond to the value of Q minus P?
All right, so a lot of letters here, but this is where we use logic and our knowledge of how numbers work to get through this. What's our first step going to be?
Well, you could plug in numbers.
Yeah, you could plug in numbers. Might be an even easier way. So we've got, I'm just going to point out that Q minus P, is P a positive or a negative number? It's a negative number. So what happens when you subtract a negative number? Susanna?
It would be positive.
Yeah, they cancel each other out. So we've got a negative, whatever that is. So it's our absolute value will be Q plus P. Now we know that Q must be something like 3, possibly, something like that. Working with what Sonia said about plugging in numbers, we'll say Q equals 3. P could be something like -2, maybe. So 3 minus -2, we cancel these negatives out. We get 3 plus 2. What do we see going on here? Do we see a pattern? What's
It has to
happening?
be greater than
Yeah, very good, very good. Your answer of Q minus P is going to have to be greater than Q. Because in any case, no matter what these numbers are, you're going to be increasing the absolute value. So what's our only option? C. Yeah. Any questions about that? So it's sort of a combination of picking numbers and using our math knowledge of how number properties work that got us really quickly to that answer. Okay, great. So we're going to be looking at some group word problems now. And let's see. I'm going to divide up into groups. Let me turn the video off.